In this video, we'll look at how Rafay's GPU PaaS implements multi-tenancy with the right security and controls in it. So let's start with this visual here. We have the Rafay controller, which is managing a host Kubernetes cluster, which has a bunch of GPUs, NVIDIA GPUs attached to it. The end user comes in and using the self-service portal creates a GPU workspace. Now, what happens behind the scenes is a Kubernetes namespace is created on the shared host Kubernetes cluster. Inside it, a virtual cluster is deployed into the Kubernetes namespace. Now let's look at the controls that are in place to ensure that this is a true multi-tenant environment. The first is a role-based access control is automatically implemented where the end user who uses the workspace will have a certain role which has a certain privilege attached to it, and they can only do a certain number of things, and they cannot see any other tenants. That's number one. Number two is in the namespace that is created, a resource quota is automatically created, making sure that the allocated capacity is all the user can use. There's a network policy automatically imposed on the namespace, making sure that the user cannot talk to the other namespaces. They ensure talk to resources on the internet and expose their applications to be, for example, an inference service or something like that. They can do that, but nothing more. The next control that is in place is we have a Rafay admission controller, which we'll double click on in a couple of seconds, which is based on kata containers. And this makes sure that the entire, the pods deployed in the vCluster on top are actually running in their own micro VM. And this ensures that there's isolation where there's no container escapes possible from the GPU workspace down to the host cluster. Next is in the almost impossible situation where a container escape does happen, there are robust turnkey policies implemented and enforced at the host Kubernetes layer based on OPA Gatekeeper. And all audit logs from this are automatically streamed back to the Rafay controller. So you have complete visibility into what is going on. Finally, everything the user does inside their workspace, anything that is done inside the host cluster, there is an immutable audit trail for all this activity that is aggregated and maintained at the central controller. Now let's look at a little more about the Rafay admission controller, which is used to auto-enable kata containers for all resources deployed inside the vCluster. So in this case, the user deploys an ML application to their workspace. And what happens is the admission controller, it automatically injects the kata runtime label to all pods belonging to the ML application, which means that they're all deployed as kata containers using the kata runtime inside that particular vCluster.